Let's see an example of a customized version of Atoms that will help you in your virtual prototyping development process. In the workshop that you're about to do, you are going to start up Atoms in this working directory, this mod1 stamper, and you'll load a file called aview.cmd. When you do this, Atoms, the commands in the aview.cmd file load up a customized environment. What I mean by customized is that you get a welcome screen with some information, and you get a model that's loaded. As well, there's a menu up top here called the Stamper menu. We'll discuss this in just a moment. Before we get started, let's talk about the actual mechanism that's shown here. So here we've got a classic mechanism design problem. You've got a stamper mechanism where there's a stamp on the end of this link, and there's a blotting pad here, this blocks, which has ink on it, and then you've got these parcels which need to get stamped. So as the conveyor belt moves along and these parcels slide along the conveyor belt, this linkage needs to get some ink from the stamp, and it needs to press down on the parcels. It can't press down too hard to crush the parcels, but it has to press down enough to stamp them properly. So this is a classic mechanism design problem, and if you take a look at this mechanism, you can see that it's got 1, 2, 3, 4, 5 moving parts. In other words, it's called a 6-bar mechanism, including ground. So 5 moving parts plus ground. And so from the Stamper menu, someone has gone in and customized the Atoms View interface, and they've made it fairly easy to make changes. When I select the Setup the Model pick, it provides this dialog box. And when I change this control link tip length, you can see what happens if I zoom in on this yellow link. You can see what happens is the link either gets smaller or larger, depending on how I set the value. At some point, if you make the value too large, you get a warning message that says, hey, the link length has to be greater than 239 and less than 269. So someone has also set up some intelligence into this design variable that is being altered here. For now, what you're going to do is modify the link length, and then you'll go run a simulation. To run a simulation, you can use the Simulate menu, and I'll run a single simulation. The output step size will be small, and I'll update the model. When I hit Apply, you can see Atoms goes and runs this simulation. It solves the equations of motion of the system, and it's showing you an animation. As it goes through, and when it completes, you get a message that says the maximum penetration is -24. So what that means is if I look at the Investigate Results panel, I can just animate the last result. And you can see what happened. When the stamper came down, it did not quite hit the top of the parcel, hence the message that says the penetration is -24. So if you go through and change the linkage length in here, and let's say I make the linkage length smaller, and then I'm going to change the output step size to be large so it runs faster. Now when I run it again, it's not even close. So it's not even close to hitting the top. If I go back and change the link length again and make it large this time, you can see you can run through a manual process of updating your mechanism and running a simulation. So that's the manual way to do things. And now that you have a virtual prototyping environment, it's very easy to rerun successive animations and change the mechanism and see how it affects the system. A better strategy, though, would be to run a design study where you just say, all right, I've got something that I want to change. I'm going to run it through a lower limit to an upper limit, and maybe run it through 10 different levels. So between 239 and 269, break this range up into 10 values and run each of those, and then give me some reports. So when I hit Apply, you can see Atoms View is running down here in the taskbar, and it ran a design study operation. Here's the summary. It said my variable value started at 239, ended up at 269, and for each value it ran a simulation, and reported the stamp height. So you can see the stamp height started out at 60 above the parcel, eventually got down to 16, 5, and then the very last one was -8. This indicates penetration. So if you were to take a look at this plot, you could transfer this plot to the Adams post-processor and try to figure out this point where the x-axis crossing is, and that would be your proper link length for the exact stamp penetration that you want. So that's another way to do things. Alternatively, you can also go and run a optimization. So if I say I want a desired penetration of 2 millimeters and I hit apply, Adams will go, and again it's running a whole bunch of simulations right now, and it says, oh, your optimization was successful. The control length of 267.38 resulted in a penetration of 2, which is what I wanted. So here's the results. Here's the number of iterations, and here's the control length that I'm interested in. So there's a number of different ways that you can exercise your virtual model. The first step is building the virtual model, and then you can intelligently exercise it. This is the end game with Adams View. You want to get to this step so that you can rerun your model as many times as possible.